Hello again, my name is Ryan Thomas, and today I'd like to explain why we hear sound the way that we do. And what it's related to is actually light and how we see colors. As we know, light comes in two forms. It's both in a particle or photon form, and then it also has a wavelength to it, meaning it travels in waves. And the reason that I believe light travels in waves is because the photons are charged. Unlike what modern science will tell you, I believe that photons hold a charge. And I believe that sound particles also hold a charge. And I'll get to that in a second. But the reason that I believe photons hold a charge is because the way their frequency changes, it becomes proportional to the wavelength. So with light, you might have a color at, say, 400 nanometers is, the wavelength, very tiny, less than can be shown with fingers, but a very tiny wavelength, which means that the photons are traveling in those wavelengths, at a certain frequency, and there's a frequency that goes along with that wavelength, and you can calculate it by using a formula and by using the speed of light. And I haven't checked in a while, but I believe it's either the speed of light divided by the wavelength will yield the frequency, or it's the other way around. And obviously you can use different mathematical concepts to play around with that. But essentially you use the speed of light to derive the proportion of wavelength to frequency. Well, what happens is these photons will have a certain frequency, and because they're charged, they're going to interact with material, and that material is going to cause them to have wavelengths. So they're not just going to be, oscillating, these photons. They're going to be, or vibrating, they're going to be passing through the air in a wavelength fashion based on that frequency, that oscillating particle. And I believe the same is true for sound. With sound, it's now these, say you got your hands and you're clapping, particles of our hand, very imperceptible particles are leaving the hands when we clap, and it's sending out these sound waves, and these sound waves are at certain frequencies, which means the particles are oscillating at certain frequencies, and they're interacting with this charged material that I'm terming spatial matter. Spatial matter is relatively low in density. Even its peak density is maybe only 1/1,000,000th of a gram per cubic centimeter, and all other densities are lower of the same material. And if you want more on that, you can see my other YouTube videos on spatial matter. But spatial matter is the same substance that causes gravity, and one of the phenomena of gravity is preventing objects like planets, moons, and stars from falling down in the vacuum of space. Spatial matter is what supports those objects and keeps them from falling downward in the vacuum of space. Spatial matter is what causes these objects to rotate. It's what causes them to orbit larger objects, and on and on and on with the phenomena that occur in the vacuum of space. You can see my other videos. Spatial matter is displaced when these objects form, and it tries to get back to where it was, and therefore it causes these things to rotate and do all those things. However, spatial matter is also charged material, and therefore anything that goes through it with a charge will also be interacting with this material, and these interactions are what cause us to see color and to hear sound the way that we do. Higher frequency photons will cause us to see different colors. Lower frequency ones will cause us to see different colors. And photons don't just give off light. There's also, or they don't just give off visible light, but they also change based on, things that we can't see. There's ultraviolet light, there's infrared. All those things are part of these photons having different frequencies to them. and having different wavelengths based on those frequencies. And what happens is the photons interact with the space matter that's around. The higher the frequency, the more that these particles will interact, and therefore you get shorter wavelengths because they're interacting more actively. These photons are interacting more actively with the space matter. And the same is true with sound. The sound particles, they leave the body or some other object, and they interact with space matter. The higher frequency sound particles will have shorter wavelengths, and therefore they'll hit our eardrums in a way that causes us to hear a higher pitched note. With the lower frequency sounds, it'll be sound particles will be interacting less with space matter, all that matter, charged material that's around us, and therefore you'll have longer wavelengths, more space in between the crests and the dips, and therefore you will have the way that they hit our eardrums, we hear a lower sound because of that. So that's why we hear sound and why we see colors, and it's all because particles which are charged and are traveling through charged material, they have no way of getting from point A to point B without this interaction, and therefore we see different colors, we hear different sounds. If there weren't any spatial matter around, assuming that these particles could get from point A to point B without just falling down, there would be a very different sound to it. And there would be a very different look to things. So that is why we can hear different sounds, and that's why sound waves have both high frequency sounds and low frequency sounds that are distinct. And it's because of the wavelengths and because of the spatial matter changing the way that we perceive things. So really it's through the spatial matter, and you can find out more by reading my books available on Amazon.com. I have a book called Why Is There Gravity? And it explains why there's gravity. There's a book called How Life Began on Earth, and it doesn't just explain how life began on Earth, it explains how life began, period, and how life evolved from energy, from this spatial matter condensing into energy, and there being lower density energy contained within the higher density energy. And so something that could be as low as 100 quadrillionths of a gram per cubic centimeter, or 100 quadrillion times less dense than water on Earth, could exist and be a life form. And that book explains that, and explains how we could all be life forms that are exactly like that, low density energy that evolved and is able to operate these high density bodies. Okay, so that's why we hear sound. Again, my name is Ryan Thomas, and thank you very much. Bye.